Okay, so I'm going to help you all with a quick tutorial on factor trees just in case anyone's having trouble. This is the one that I assigned the other day. So this is your factor tree that starts with the 45 on one side and the other side of it has the 70 and the small little boxes. So we're going to start with this side with the 45, and they've already given you one of the numbers. So you have to look for the other number that you can multiply by 5 to make 45, and that would be 9, because 9 times 5 equals 45. Now they're showing you bringing this one down because you just want to keep working all of your numbers all the way down the page. So the 5 would just come down because 5 is prime, meaning the only numbers you can multiply together to make 5 are 5 times 1. Then 9 can be broken down into 3 times 3, which leaves you with your prime factorization of the number 45. 3 times 3 is 9 times 5 is 45. Whatever you have on this bottom line should equal the number that you have there at the top. So for your second one, you have 18, and then you have 3 here. Well, we know that 3 times 6 equals 18, so we can fill that in. The 3 simply needs to come down because it is prime, and on this side, 3 times 2 is going to equal that 6. And again, if I multiply 3 times 3, it's 9 times 2 is 18, and so that gives me the number that I see up there at the top. Okay, I'm gonna just break one down on a piece of notebook paper as well, but really quickly I'm gonna show you what they're doing back here. So here you have one prime number and you have a number that is not prime. So there are different options that you could put in here. You could put a 2 and a 35 in here, but I'm gonna go ahead and put a 7 here and a 10 here, just because I think that's more the way your brains will think. 7 is already prime, that's why you don't see anything else here. And then the 10 on this side can be broken down into 2 times 5. So my prime factors are 7 times 2 times 5. And if I were to multiply those together, 7 times 2 is 14 times 5 does equal 70. I'm looking for these numbers to equal that first number. So let's do one of them on a piece of notebook paper. Let's just do the number 108. Seems a little more difficult, but I think you all can handle it. So on the number 108, it can be multiplied by 12 times 9 equals 108. And you need to make sure you make your numbers pretty far apart so that you can continue to break them down. I can still break 12 down further by 3 times 4 equals 12. And my 9 can be broken down as 3 times 3 equals 9. Any numbers that are already prime, I'm just going to keep bringing them down. So 3 is a prime number. I can't multiply anything besides 3 times 1 to make 3. This 3 can then come down. This 3 can come down. 4 can be broken down into 2 times 2, and now I'm left with all my numbers on my bottom line. So I would have 3 times 2 times 2 times 3 times 3. And if I multiply those together, 3 times 2 is 6, times 2 is 12, times 3 is 36. And if I take 36 and I multiply it times 3, I get 108. So that's my prime factorization, or my factor tree, for 108. Let's do one more together. Let's do the number 54. And I'm going to start 54 off as 9 times 6. And both of those numbers are not prime, so I can break them down further. 3 times 3 and 3 times 2. And now all that bottom line is all prime, so now I can write my prime factorization. 3 times 3 times 3 times 2. And I want to always multiply in my head to make sure that I get the answer. 3 times 3 is 9, times 3 is 27, 27 times 2 is 54, so that is correct. So hopefully that helps you a little bit with your factor trees.